AI moves fast. Here's what matters. This is AI Daily for January 12, 2026. After Grok's launch, regulators were less concerned with its helpfulness and more focused on the 73 deepfake videos it allegedly helped users create of pop star Anya Sharma. Now, X is facing restrictions not for tweets, but for what its AI can conjure in the dark corners of the internet. Today, OpenAI is reportedly asking contractors to upload real work, new information extracted from Snowden PDFs through metadata. Plus, our deep dive into X and Grok face restrictions over AI-generated deepfakes. Let's go.
Here's your AI Daily News Roundup for January 11th, 2026. All right, folks, let's jump right in. First up, a somewhat concerning story coming out of OpenAI. TechCrunch AI is reporting that they're allegedly asking contractors to upload real work from their past jobs for some undisclosed purpose. Now, why does this matter to us? Well, intellectual property, plain and simple. As an AI practitioner or software engineer, your code is your intellectual property. If OpenAI is training models or even just experimenting on code that wasn't explicitly licensed for that use, there could be major legal battles down the line. Plus, if your proprietary algorithms are being ingested, that could significantly impact your competitive advantage. Keep a close eye on this. It might set a precedent for how AI companies approach data acquisition in the future. And it's a good reminder to be super clear about IP ownership and usage rights in your contracts. Moving on, some interesting updates in the PyTorch world. The PyTorch releases have a couple of notable commits. First, a change related to symmetric memory management. Specifically, the enable sim mem for group function is being deprecated. Now, for those of you neck deep in distributed training, this might seem minor, but it highlights a crucial evolution in PyTorch. It shows a streamlining of the API. Accessing the process group store is now handled directly through processgroup.getStore, which simplifies the codebase and ideally reduces the cognitive load for engineers working on large-scale models. Fewer, more consistent API calls make for cleaner and less error-prone code. Also, a couple of rapid updates. CI flow/VLLM 172175 and CI flow trunk 172175, both updating VLLM commit hashes. And CI flow inductor 172176, a change to the underscore compute local shape and global offset API. These frequent commits demonstrate the rapid development and refinement still happening at the core of PyTorch. We need to pay attention to these rapid changes because they mean our pipelines and even our assumptions about how PyTorch works might need to be revisited regularly. Staying up to date on these lower-level changes is crucial for maximizing performance and avoiding compatibility issues down the line. In other news, Hacker News is buzzing about some fresh information extracted from the Snowden documents. A researcher has apparently dug up new details through metadata version analysis. So why does this matter to us as software developers and AI engineers? Well, firstly, it's a potent reminder of the vulnerabilities inherent in even seemingly secure systems. We're constantly building and securing AI models and applications, but this showcases how even overlooked metadata can be a significant security risk. It highlights the need for robust, multi-layered security, including comprehensive metadata sanitization. Secondly, it showcases the power of sophisticated data analysis techniques. Thinking about this in the context of AI, these same techniques could be applied to other datasets for both good and for ill. It raises ethical questions about the potential misuse of AI-powered analysis for uncovering sensitive information. Also making waves today, another story from Hacker News concerning the UK government. Apparently, they are exempting themselves from some aspects of a new cyber law. This is raising some serious eyebrows and sparking little confidence in, well, anyone. From our perspective, this is significant because it raises the question of accountability in the AI space. As AI systems become increasingly integrated into critical infrastructure and government services, the question of who is liable when things go wrong is paramount. If governments are carving out exceptions for themselves, it could create a dangerous precedent, potentially hindering innovation and eroding public trust. It's a reminder that the legal and ethical frameworks around AI are still evolving and need to be carefully considered. That's the news for today. Now let's dive into our deep dive topic, exploring the practical implications of federated learning for edge AI applications. I was scrolling through Hacker News, and I saw this story about X and Grok getting slammed for deepfake generation, and my first thought wasn't, oh, that's shocking. It was, of course this happened. It feels completely inevitable.
Totally inevitable. It's the classic move fast and break things playbook applied to a technology that can break things in a profoundly personal and damaging way.
Exactly. But here's the part I can't square. We've had NSFW classifiers and content moderation for what, 2 decades? We know how to block a static image. So why are these massive, supposedly super intelligent generative models so spectacularly bad at it? It feels like we've gone backwards.
Yeah, so the fascinating thing is that it's an entirely different kind of problem. A classic CV model for moderation is a stateless function, right? Input image, output classification, NSFW or not NSFW. It's a one-shot deal. But a generative model, whether it's text or an image, is a process.
A process? What do you mean? It's still just taking a prompt and outputting a thing.
Think of it like this. For a language model, it's generating one token at a time. The moderation can't just happen at the end. If you wait for the full explicit paragraph to be written before you flag it, you've already wasted all those GPU cycles.
For an image, the diffusion model is iteratively denoising from a random state. The decision to make something explicit happens gradually over dozens of steps.
Okay, so you're saying you have to moderate the intent of the prompt or the generation process itself, not just the final artifact.
Precisely. And that's where it gets messy. Simple block lists are useless. Users immediately figure out they can use leet speak or euphemisms. The real challenge is semantic understanding. The prompt, photograph of a woman in a bathing suit on a beach, is fine. But a tiny nuance change to that prompt can make it absolutely not fine. A simple regex isn't going to catch that.
This sounds like a job for another AI, a moderator AI.
It is, and that's the architecture a lot of platforms are moving towards. You see it in tools like NVIDIA's Nemo guardrails or the open-source Guardrails AI library. They're not just simple input-output filters. They're designed to be conversational state machines.
State machines. Okay, unpack that. If I'm a developer using LangChain to build a chatbot, how does that actually work in my code? Am I just wrapping my LLM call in another function?
Basically, yes, but it's a very smart function. Instead of just passing the user's prompt directly to your core model, say GPT-4 or Llama 3, you first pass it through the guardrail. The guardrail might have its own smaller, faster LLM. Its job is to check the user's input against a set of predefined policies. For example, a policy might be the bot should not generate unsafe content.
But how does it define unsafe? Is it just a prompt it sends to its own little LLM, like, is the following user prompt asking for unsafe content?
That's one way, called a self-critique chain, but more robust systems use something called Golang, or a similar modeling language. You can define canonical forms for user intent. For example, you define a flow like, user expresses intent to generate explicit image. Then you provide a bunch of examples of what that looks like. The guardrail model uses semantic search, probably against a vector database like Pinecone or Weaviate, to see if the incoming prompt is close to any of those banned canonical forms.
Huh, so you're not just keyword searching, you're checking for semantic similarity in the vector space. That's clever. But it also sounds slow. Now I have 2 LLM calls for every user turn, plus a vector database lookup. What does that do to my time to first token?
That is the billion-dollar question, and it's a huge engineering trade-off. Your guardrail model has to be small and incredibly fast, maybe a distilled version of a larger model or a highly optimized SLM. You might run it on a different hardware instance, maybe even a CPU-optimized one to save costs, while your main generator runs on the big H100s. The latency hit is real, but the alternative is letting your platform get flooded with deepfakes and getting shut down.
Right. So the architecture isn't just client to API to LLM, it's more like client to API gateway to pre-filter service, guardrail, to main LLM service, to post-filter service to client. That's a lot more complex.
Exactly, and each of those arrows represents a potential point of failure and a source of latency. As a platform engineer, you have to decide where to put these checks. The pre-filter, the prompt checker, has to be synchronous. It's a blocking call. But the post-filter, the one that checks the final generated image or text, could maybe be asynchronous.
What do you mean? You can't show the user a deepfake and then say, oops, sorry, that violated our policy 10 seconds later.
No, but you might have a tiered system. You do a quick, synchronous check on the output for obvious violations, maybe a fast classifier model. But for more subtle stuff, like checking if an image is a deep fake of a specific public figure, that might require a more intensive model. So you might show the image, but queue up a background job. If that job flags the content, you can then take it down, shadow ban the user, and add the hash of that image to a block list.
Okay, that makes sense from a system design perspective. You're balancing user experience with moderation thoroughness. So if you're building this on, say, AWS, you might have your synchronous path going through an API gateway to a SageMaker endpoint, and that endpoint's response also triggers a Lambda function that kicks off an asynchronous analysis pipeline.
Perfect example. That Lambda could use something like Amazon Recognition for content moderation, or it could spin up a container to run a more specialized open source model. The key is that you're separating the immediate user-facing moderation from the deeper offline analysis. You're treating it as an event-driven architecture.
Let's talk about the images themselves, because that's the core of this Grok controversy. It's not just text. How do you stop a diffusion model from generating a specific person's face? It's not like you can just add Taylor Swift to a text block list because people will immediately use variations or just describe her.
This is where the interventions get really deep into the model itself. One of the most effective techniques is called concept erasure or concept ablation.
That sounds intense. Are you actually modifying the model weights?
Yes, but in a very targeted way. The idea is you fine-tune the model, but instead of teaching it a new concept, you teach it to forget an existing one. You could use a technique like LoRA, low-rank adaptation, to train a small set of anti-weights. When you're running inference, you merge these anti-weights with the base model, and they effectively nullify the model's ability to generate a specific face, or a specific style, or any other concept you want to remove.
So if I'm deploying a model like Stable Diffusion XL on my own Kubernetes cluster using Kserve, I wouldn't just be pulling the base model from Hugging Face. I'd have a CI/CD pipeline in GitHub Actions that, after pulling the base model, applies my company's custom LoRa patch for safety before building the final Docker image and deploying it.
That is exactly the modern workflow. Your safety guardrails become part of your model artifact registry. It's not just a config file, it's a set of weights. This is way more robust than a prompt filter because it works even if the user finds a clever jailbreak prompt. The model fundamentally has a harder time accessing the concept.
But what about the unknown? You can't apply a LoRa for every single person on the planet. What happens when a user tries to generate a deepfake of their non-famous neighbor?
Right. You can't erase concepts you don't know about. So that's where another layer comes in, watermarking and provenance. This is the C2PA standard, the Coalition for Content Provenance and Authenticity. Big players like Adobe, Microsoft, and Google are all behind it.
I've heard of C2PA, but I always thought of it as just metadata. How does it work from a developer's perspective? Is it just an EXIF tag?
It's way more sophisticated. Think of it as a cryptographically signed nutrition label for your content. When your AI model generates an image, a C2PA-enabled library will create a manifest. This manifest includes details like this image was generated by AI, which model was used, what the prompt was, if you choose to include it, and any modifications made. This entire manifest is then cryptographically signed with a private key and embedded directly into the image file itself.
So if I'm building an app that lets users generate images and I want to be a responsible platform, I'd need to integrate a C2PA SDK. After my diffusion model spits out the raw pixels, I'd pass that data to the SDK, which handles the manifest creation, signing, and embedding before I save the final JPEG or PNG and send it to the user.
Exactly. And then, downstream, any application or platform that receives that image can use the public key to verify the signature. They can see that the image came from your service and that it was AI generated. It doesn't prevent the creation of harmful content, but it creates a chain of custody. It makes it much harder for bad actors to pass off AI-generated fakes as real photographs.
And if someone strips that metadata out?
They can, but the absence of a valid C2PA signature on a piece of media will increasingly become a red flag in itself. Platforms could start downranking or flagging content that lacks provenance information. It's about shifting the default expectation.
Okay, this is connecting some dots for me. The failure at X isn't just one thing. It's a failure of prompt sanitization, a failure of in-flight generation monitoring, a lack of model-level concept erasure, and a lack of output provenance. It's a full-stack failure.
It's a full-stack safety architecture failure, and it shows that you can't just bolt on safety as an afterthought. You have to design for it at every single layer, from the API gateway down to the model weights. The term people are starting to use is AI safety ops, treating safety with the same rigor as DevOps.
So let's make this super practical. Let's say I'm a senior engineer on a platform team and my company wants to start integrating generative AI features. After hearing about this X disaster, my VP is freaking out. What's my three-point plan? What do I tell them we need to build?
Great question. I'd break it down into 3 layers of defense. First, the perimeter. This is your API gateway and your prompt filtering service. It's your first line of defense. Use a fast, cheap model or a vector database with embeddings of known bad prompts. Your goal here is to catch the 80% of low-effort attacks and blatant policy violations with minimal latency.
Okay, so that's the synchronous blocking part. What's layer 2?
Layer 2 is the core. This is the model itself. Don't just grab a base model off the shelf. Work with your ML team to apply safety fine-tuning. Use techniques like concept erasure for high-profile public figures or specific brand safety concerns. This is your most powerful but also most expensive line of defense. And if you're using a third-party API like OpenAI or Anthropic, this means really digging into their safety documentation and using the moderation APIs they provide. Don't just assume the base model is safe by default.
Right. Use the tools the vendor provides. Don't try to outsmart their safety team. And the third layer?
The third layer is postmortem and provenance. Every single generation, good or bad, gets logged. The output gets sent to an asynchronous analysis pipeline. You're looking for new attack patterns, subtle jailbreaks that got through the first 2 layers. This is also where you implement C2PA watermarking. You're creating an audit trail and ensuring the content you produce is identifiable. This layer doesn't stop an initial bad generation, but it lets you learn from it, patch the holes, and prove you're acting responsibly.
So it's a feedback loop. The async analysis from layer 3 informs the block lists and semantic filters in layer 1, and maybe even identifies new concepts you need to erase in layer 2?
That's the whole game. It's not a static wall. It's an immune system. It has to constantly adapt because the threats are constantly evolving. The moment you deploy a new guardrail, there's 1,000 people on a forum somewhere trying to figure out how to bypass it.
That makes a lot of sense. So the big takeaway here isn't just X messed up. It's that content safety for generative AI isn't a feature you add. It's a fundamental distributed systems problem that has to be woven into the entire stack, from ingress to inference to exis.
Exactly. It's an architectural choice. And for developers and platform engineers, it's a huge new area of specialization that's going to be incredibly important. Being the person who knows how to build a robust, multi-layered AI safety stack is going to be a very valuable skill.
That's AI Daily for today. If you found this valuable, take a second to subscribe wherever you get your podcasts. And if you're on YouTube, hit that like button. It really helps us reach more people in the AI community. For deeper dives and weekly roundups, sign up for our newsletter at aidaily.sh. Share this with a colleague who needs to keep up. See you tomorrow.